I am going to go through number 9 from paper 1, HL, Math Applications and Interpretation, November 2022, IB exam. So here we have number 9. We are given a transformation matrix, M, and we're told that a pentagon has an area of 12 centimeters squared and it gets transformed. And we're asked to find, for part A, the area of the image, so the transformed area. A couple things about matrix transformations. If we have a point or a position vector that gets transformed, any point that gets transformed, it could have both transformations, which we can represent here by matrix M. We multiply that by x, by our position vector or point, and any translations at any translation vector we would add, and that will give us the image of our new point. So in other words, we take our old point, multiply it by the transformation matrix, and if there happens to be any translations involved, those will be represented by an additional vector that we would add. Here, we don't have any translations. It's only talking about rechanging the just transformations, so this is all we have to worry about. And the other thing is that we can find the new area by taking the determinant of our transformation matrix, its absolute value, and multiplying that by the original area. So the area of the original object, I'll call that O, if we multiply it by the determinant of matrix M, that gives us the area of the image. So for A, all we have to do is find the absolute value of the determinant. The determinant is just 2 times 1 minus negative 4 times 3, which is 2 plus 12 or 14 times, so then we multiply that by our area of the original, which is 12, and that gives us an area of 168 centimeters squared. That's A. B, we're going to go back to use this formula. We get our transformed image by multiplying the transformation matrix by our original XY point and find our new point. Well, this time for part B, we're given the image, and so we can write that with its position vector: 2t minus 3, 6 minus 5t would be equal to matrix M, or 2, negative 4, 3, 1 times xy, times the original point. And we're trying to find the original coordinates of x in terms of t. By doing this, we can create a system of equations. We can we can multiply these two matrices on the right, giving us 2 times x. I'll change colors here so we can see. 2 times x, or 2x, plus negative 4 times y, or minus 4y. That will give us the top row, and then 3x plus y for the bottom row, and that will be equal to this matrix. So now we can just set the rows equal to each other. 2t minus 3 equals 2x minus 4y, and 6 minus 5t equals 3x plus y. And we are asked to give the coordinates of the point x in terms of t. So we want to eventually get a value for x in terms of t and a value for y in terms of t. Here we have, so what I would suggest is maybe just going ahead and seeing if we can cancel out one of the variables I'm noticing that here we've got a y and a negative 4y, so I'm going to multiply the bottom equation by 4. And I'll just keep that. Rewriting that, we get 4 times 6 is 24, minus 20t equals 12x plus 4y. And now when we add the top equation to the bottom equation, we end up with, let's see, we're not quite in order here, but that's okay. We've got a 2t and a negative 20t, so that is negative 18t. We have a 24 and a negative 3, so that is positive 21. We have a 2x and a 12x, so that's 14x, and then the 4y's cancel. Here we're almost finished. We almost have it x isolated. We just have to divide both sides by 14. And that gives us x on the right. And negative 18t over 14, I'm going to go ahead and reduce that by 2 to get negative 9 over 7t. And 21 over 14, I'll reduce that by 7s to get 3 over 2. And now I have the x-coordinate of my original point in terms of t. I'm going to use that x-coordinate to find y, and then I'll be done. So I take that value, find one of these original equations that are pretty messy right now, but I'll just take the top one and put that in the place of y. So that top equation was 2t minus 3 equals 2x. In place of x, I'm going to do negative 9/7 t plus 3/2 minus 4y. And my goal here is to isolate y. So I can distribute, and I get 2t minus 3 equals negative 18 over 7 plus 3 minus 4y. Oh, there, I left out a t there. And moving everything to the other side that I can, adding 18 over 7t. I think that gives me 27, negative 27. No, that's not right. Change that 2 to 2 over 1, which becomes, make it over 7. So 14 over 7. I guess I should write out what I'm doing here. I'm going to be adding 18 over 7t to both sides, plus 18 over 7t, which is why I changed that 2 to a denominator of 7. And I'll be subtracting 3 from both sides. Okay, so now I have 14 plus 18 is 32 over 7t. And then minus 6 equals negative 4y. And now I just need to divide by 4. Dividing everything by negative 4. Okay, almost here. We get y equals, when I do negative 6 divided by negative 4, that's 3/2 positive. And when I do 32 over 4, I'm going to write this out to the side. 32 over 7 divided by 4 is the same thing as 32 over 7 times 1/4. Before I multiply, I'm going to go ahead and just cross cancel. 32 and 4 have a common factor of 4. 4 becomes a 1, the 32 becomes an 8. And now that's just 8 over 7. So 8 over 7t. And that's my y. Okay, so we were asked to find the coordinates of x, and we've done that. We found the x coordinate of the x point and the y coordinate of the y point. And we're done. Phew.